Hello students. In previous class we have studied about the irrational number. So in today's class we will study how to represent or how to locate the irrational numbers on the number lines. Okay. So three examples we will see: root 2, root 3 and root 5. How to represent this number on the number line. Okay. So first of all we will represent root 2 on the number line. So to represent root 2 on the number line, first of all we will take some unit distance. That means here you have to take you can take 1 centimeter or 1 inch or any distance, but it should be 1 unit. Okay. So same distance you have to take to the perpendicular to this line. Okay. If you have to take 1 centimeter here, then you have to take 1 centimeter to the perpendicular to this line. If you have taken 1 centimeter 1 inch, then you have to take 1 inch. Okay. It is not necessary to take centimeters or inch. You can take more greater distance as a unit distance. Okay. If you cannot uh, represent on 1 centimeter scale, then you can use 5 centimeter as 1 unit. So you have to take it, this OA is equals to 5 centimeter, but you have at the same time take AB is equals to also 5 centimeter. So but we have to represent it as 1 unit, right? That means OA is equals to AB. This is the necessary conditions. Okay. So now if we take OA and OB is equals to 1 unit and join OB, right, then this is a triangle OAB and it is a right angle triangle. So because here angle A is 90 degree. Okay. So according to the Pythagoras rule, if any triangle is a right angle triangle, then we can write down that OB square, that is the hypotenuse, OB square is equals to OA square plus AB square. Okay. So now OA, what is the value of OA? 1. So OA is 1 square plus OB, AB, again AB is 1. So here also we have to take 1 square. So this is 1 square is 1 square is 1. 1 plus 1 is equals to 2. So OB square is equals to 2. Now if we take square root both the side, then here we get OB and here we will get root 2. So now we know that OB is equals to root 2. So we can write down here that OB is equals to root 2. Okay. But we have to represent this root 2 on the number line. So we take this whole portion on the number line, right? So here our OA is 1 unit, AB is 1 unit. So obviously OB we will get is root 2. Okay. So now this is root 2. So to represent this distance on the number line, we will use the compass. Okay. So take your compass, right? Take OB distance and make an arc, right? Okay. So this point is suppose P point. So our OP distance is equals to OB distance and it is equals to root 2, right? So in this way we can represent root 2 on the number line, right? Here O, we suppose that O is the 0, right? So from starting from the 0 up to P is our root 2 distance. Okay. So in this way we can represent root 2 on the number line. Okay. Now in this same case, in the same way, we can represent root 3 on the number line. Okay. So how to represent root 3 on the number line? So we will use this diagram again to represent root 3 on the number line. Okay. So we will add one step in this diagram. Here we have take a perpendicular line to this line, right, as one unit. Now in the same way we have to take one more line. See here, we have to take one unit more which is perpendicular to this line, which is of root 2, right? So here we have to take a 90-degree angle and we have to extend this up to 1 unit, right? Now suppose this is a point C. Join C to O again. So here we will get another right angle triangle, that is OBC. Okay. Again we will use the Pythagoras rule. So in triangle OBC, now OC is our hypotenuse. So according to the Pythagoras rule, OC square is equals to OB square plus OC square is equals to OB square plus BC square. So what is our OB? We know that we have previously shown that OB is equals to root 2. So here OB is equals to root 2. So it is root 2 square plus BC is equals to 1. So 1 square. So what is root 2 square? Here square and square root both cut each other. So we will get only 2. And 1 square is 1. So 2 plus 1 is equals to 3. This is our OC square. OC square is 3. So by taking the square root both the side, we will get OC is equals to root 3. So now this distance OC is our root 3. Again we have to represent on number line. So we will take this much of distance on the compass and make an arc to this point OP, right? In this way, see, O to C and mark this on the number line. So this is our point P. Now we know that OC distance is equals to OP distance, right? As OC is equals to root 3, so OP is also root 3. So if this is our 0, then this distance is our root 3. So in this way we can represent root 2 and root 3 on the number line. Now we will represent this root 5 on the number line. Okay. Okay. So as we have represented the root 3 on the number line, in the same way we can represent root 5 on the number line. So here up to root 3 we have studied how to represent root 3 on the number line. So now for the next step, again we have to take one unit from this root 3 line which is perpendicular to this root 3 line, right? So this is our one unit C to D which is perpendicular to OC. So now we will know that if this is root 2, this is root 3, then this distance will be root 4. Okay, but we want root 5 on the number line. So again take one unit D to E which is perpendicular to this OD, right? And join E to O. So by joining O to E, now this is our root 5. Okay. So now by taking an arc O to E and represent it as on the number line, right? As we know that OE and OP is the same radius of a circle. That means this distance OE and OP are equal. So now here our OP is equals to root 5. Okay. This method of representing the irrational number on the number line is called the spiral method. In another method, we can represent root 5 on the number line. So this is the second method. So to represent root 5 on the number line, this is the second method. So how to represent? We know that 5 is equals to 4 plus 1. Okay, as 4 it is the perfect square of the 2, because 2 square is equals to 4. So what we will do here, first of all we have to take 2 unit distance, right? Remember one thing, in previous case we will take only one distance in each case, but here we have to take 2 unit distance, right? So if this is our 0, 1, 2, so this is our total 2 unit distance, right? If you have taken it 0 to 1 as 1 inch, so you have to take total of 2 inch. If you have taken this as 1 centimeter, then you have to take this total as 2 centimeter. Okay, so now take perpendicular from this 2 unit distance OAB, and this we have to take as 1 only, 1 unit. Okay, so suppose this is our point O, this is our point A, and this is our point B. Okay, so now this B point we have to join to the point O. Okay, so now this triangle OAB is a right angle triangle. So according to the Pythagoras rule, OB square is equals to, because OB is here hypotenuse, OB square is equals to OA square plus AB square. So what is our OA? OA is our 2 unit. That is why we will take 2 square plus OAB is equals to 1 square. So this will be 4, this is 1. 4 plus 1 is 5. Now by taking the square root both the side, we will get OB is equals to root 5. Okay, so this is our root 5. Again, to represent this on the number line, we will take this much of distance in compass and make an arc on the number line. Okay, so this distance from O to P is root 5. Okay, so in this way root 5 we can represent in both the ways. Okay, so which kind of number we can directly represent in this way or not using the spiral method? So to represent this kind of number, we have root 10, root 17 or root 26. This means this number is a perfect square. So one number more than perfect square number we can represent directly in this way. Okay, so this is all about to represent the irrational number on the number line. Okay, thank you.